Let's analyze quadratics that are in root form. Let's say we have a quadratic equation y equals x plus 2 times x minus 4, and we want to find the vertex, axis of symmetry, min or max, domain, range, and roots. We can actually say the domain right away, regardless of which form of quadratic we have. If it's a parabola, then domain is all real numbers. So we can say x belongs to all real numbers. Or we can say negative infinity to infinity. That would be our domain. Now the range depends on where the vertex is and which way the parabola opens, up or down. So since we are talking here about the root form, let's first say what the root means. Root is same thing. So roots are same thing as x-intercepts, or same thing as zeros of a function. And it's the same thing as solutions. So either one of these refers to the same point. They might have a slightly different meaning, but they refer to the same points on the x-axis. And why are these points on the x-axis? Well, they are x-intercepts. And if we are talking about x-intercepts, that means we are talking about the points at which the function hits the x-axis, right? Now, if we are talking about x-intercepts, that means the y-coordinate is actually equal to 0. So to find intercepts or zeros or roots or solutions, what we need to do is equal our equation to 0, because y needs to be 0. So what we need to say, 0 equals, and then we copy the rest. Now, if the function is in factored form, then it's also in root form. So root form is simply just the factored form. So this is already in root form. And if we are in root form, then we should be able to find the roots pretty quickly, practically read them almost off of the expression. So if we have the right-hand side that looks like this, and it needs to be equal to 0, what needs to happen is this needs to be 0. And if this is 0, then it doesn't really matter what this is. When we multiply by 0, it's going to give us to 0. The same thing applies to this factor. If this factor is equal to 0, then it doesn't really matter what is this factor equal to. When it multiplies by 0, it's going to be equal to 0. So with that being said, all we need to do is equal each of these factors to 0 and figure out which value of x will actually give us, make the expression equal to 0. And then x minus 4 equal to 0. So here, if we solve for x, we move 2 to the other side, so x is going to be equal to negative 2. And then here, we move negative 4 to the other side, so x is equal to 4. These are our two roots. These are the values of x that would make us hit the x-axis. So we found the roots, negative 2 and 4. So they are right here, 1, 2, so negative 2, 1, 2, 3, 4, so this is 4. So we have those 2 points, those 2 roots. Now, if we have roots for the quadratic function, then what we can do is we can read the axis of symmetry, or find the axis of symmetry. The axis of symmetry is actually always going to be halfway between the 2 roots. And if that's the case, then our axis of symmetry is right here at x equal to 1. So let's draw it as a dotted line. So this is our axis of symmetry, and equation of it is x equal to 1. So this is axis of symmetry. So let's write it down here, x equal to 1. And if we know axis of symmetry, we know x of the vertex, because the axis of symmetry is going to go through the vertex. So we know that x coordinate of the vertex is 1. Now to find the y coordinate of the vertex, all we need to do is take this 1 and put it into our equation. Plug it in, as we say. So take 1 and replace x with it. So if we do it, what we get is, so y equals 1 plus 2 times 1 minus 4. So this here is 3, this here is negative 3, so y is equal to negative 9, right? 3 times negative 3 is negative 9. So the y coordinate of the vertex is at 1 comma negative 9. So negative 9 is somewhere, let's say right here. So our vertex is going to be 1 comma negative 9, right there. Let me just move this over a little bit. Okay, so now if we have these 3 points, that should be sufficient enough to actually get our parabola. So let's try to draw it. So it's going to go here, make a turn, and then go up here. And of course it keeps going up towards the infinity. Okay, so we see that our parabola is facing up, opening up, which means the vertex is the lowest it can go. And then how low can it go? It can reach negative 9, and then nothing below that. It can take any value above that, like negative 8, negative 7, 6, and so on, positive million, but never go below negative 9. So we know that we have a minimum of this function, and the value of it is negative 9. Now that same vertex and that same value defines our range. The range of this function starts at negative 9, and then so starts right here, and then any value after that, any y value after that, is going to be part of it. So range is everything from negative 9 all the way towards infinity. And then we need to put a bracket here because we want to include the 9. We could also say, well, range is any y value that's greater than or equal to negative 9. Thanks for watching. There are some more videos about analyzing quadratics, such as quadratics in standard form, as well as quadratics in vertex form. This video was about the root form. Thank you for watching again.